Have you ever wondered what the planets looked like in the early stages of the solar system? How planets like Mercury and Venus are so close to Earth yet ended up looking entirely different? Or if gas giants like Jupiter and Saturn have always been as massive and gassy the way they are now? Well, it'll interest you to know that all the planets in the solar system have gone through similar yet completely different cosmic stages to reach where they are today. Join us in today's video as we answer a very vital question. What were the planets like 3.8 billion years ago? You might be asking why we decided to look at 3.8 billion years ago, and not the very beginning of the planet's formation. Well, that's because during this period, the planets had finished the formation of not just their cores, but had established themselves as either gas giants like Jupiter, Saturn, Uranus, and Neptune, or terrestrial planets like Mars, Earth, Venus, and Mercury. Also, it was during this period that the planets were ending a period known as the Late Heavy Bombardment Period, a time when all the planets in the solar system were constantly being bombarded by asteroid impacts. These asteroids were the remnants of the early solar system and formed from the gas and dust that didn't accrete into the bodies of any planets. They were constantly being tossed around by the new gravitational diversity of the solar system exerted not just by the Sun, but also by all the newly formed planets, especially giants like Jupiter and Saturn. So, what did each planet look like 3.8 billion years ago? Well, let's start with the gas giants. The gas giants. At this point in the solar system's evolution, Jupiter, Saturn, Uranus, and Neptune had established themselves as gaseous planets, and they were the biggest gravitational forces in the solar system after the Sun. As such, these planets are believed to have received much of the asteroid impact during the Late Heavy Bombardment period. But unlike the terrestrial planets, these gaseous planets weren't all that affected by the constant impact from asteroids, and their general outlook hasn't changed that much. This is because these planets are almost entirely made of gas, and as such, the asteroids merely sank into the endless depths of clouds and dust. The size or speed at which the asteroids impacted the planets didn't make much difference, as they were simply swallowed up underneath the huge ball of gas clouds. Although this means that the late heavy bombardment didn't change the gaseous planets that much, scientists do believe it did have an impact on the color and patterns found on the surface of these planets. These asteroids introduced foreign minerals and compounds into the gas clouds of these planets, causing the variation of colors we now see on the surface of planets like Jupiter and Saturn. These asteroids also caused strange vortexes and cyclones to form in the areas of impact, and many of these vortexes have been spinning for billions of years. But other than that, astronomers believe the gaseous planets have remained relatively unchanged since the late heavy bombardment period, except for the number of moons these planets have. Planets like Neptune and Jupiter have been found to have captured some of their numerous satellites as recently as 2 billion years ago. Moving on to the terrestrial planets. These planets have gone through more severe and noticeable changes compared to the gaseous planets. Some of these changes we can even see on the surface of this planet today. Mercury. Starting things off, you have Mercury. During the late heavy bombardment, Mercury didn't have a surface of clouds or even much of an atmosphere to deter the constant stream of asteroid impacts. As such, much of the asteroid impacts devastated the surface of the planet drastically. With the constant stream of asteroid impacts and its proximity to the Sun, Mercury has been termed to have been a hellish planet with surface temperatures exceeding 4,000 degrees Celsius. Also, Mercury was volcanically active, and with a constant stream of molten magma erupting from deep within the planet's core and a steady stream of asteroid impacts, the surface of Mercury constantly changed. Mercury also has one of the largest impact craters in the solar system, the Caloris Basin, measuring over 1,500 kilometers wide. The impact that resulted in this depression must have been incredibly powerful, as the outer edges of the crater measure up to 2 kilometers high, higher than most mountains on Earth. Images from the MESSENGER probe show that the surface of Mercury remains heavily scarred by the impact of these asteroids, but although it is closest to the Sun, temperatures have reduced to less than 170 degrees Celsius. Venus. Today, Venus is the hottest planet in the solar system, with surface temperatures reaching 470 degrees Celsius, and while it had a similar origin to Mercury, it didn't have the same journey to its current state. Like the other planets, Venus also received a huge amount of asteroid impact during the late heavy bombardment. And while that also led to enormous craters, something else happened in the planet's history. Astronomers believe that, like Earth, Venus received a fairly large amount of comet impacts, which might have led to the planet having water on its surface some 3 billion years ago. As we know, comets are the largest reservoirs of ice in the solar system, which, under the right atmosphere, can form water on the surface of planets. It is possible Venus was able to condense this ice to water and could have even had some forms of life at a time when the Earth was still a hostile ball of fire and rocks. But somewhere along the way, something went wrong, and the planet began accumulating obscene amounts of carbon dioxide, increasing the surface temperatures till all the water evaporated. These greenhouse gases reached toxic levels that Venus became extremely hot, with its clouds trapping heat and raining sulfuric acid instead of water. Today, Venus is even hotter than Mercury and far more volatile. Earth. By our standards, Earth is the most beautiful planet in the solar system, with temperatures and pressures just right to sustain life. But the Earth was a completely different place 3.8 billion years ago. Following the late heavy bombardment, the Earth was marred in immense heat on both its surface and as deep as 400 kilometers underground. These led to violent volcanic eruptions that produced seas of molten magma that were active for millions of years. At this period, Earth wasn't blue as we see it today, but was a pale orange due to the methane-rich atmosphere caused by an increased level of greenhouse gases. But over a few million years, Earth's surface temperatures cooled and water began to form, resulting from comets crashing on the planet's surface, and even possibly ice trapped within the Earth's outer core during its early formation stages. As early as 3.5 billion years, Earth already had an established magnetic field that protected the water from being irradiated away by the solar wind. Greenhouse gases also kept the oceans from freezing, and with the sun being only 70% as bright as it is today, the ocean stayed warm enough for bacterial life to begin forming. These cyanobacteria, also known as stromatolites, consumed solar energy as food and filled the atmosphere with oxygen as a waste product. This free oxygen reacted with the solar wind to form the ozone layer that protects us from solar radiation today. Seismic activities caused constant earthquakes that pushed plate tectonics to form supercontinents, which periodically broke up and converged over the next 3 billion years, long before the first complex life forms formed. Although the Earth did have water and oxygen all those billions of years ago, present life forms still might not have survived, as those conditions were still extreme compared to those found on Earth today. Mars. Mars is the only other planet that scientists believed shared the same timeline with Earth in terms of activities that followed the late bombardment period. The red planet was also exposed to a constant stream of impact from comets and icy asteroids that filled it with water. Several exploration probes have found evidence of lakes and rivers, which indicates that Mars definitely had liquid water on its surface at some point in its history, maybe even more recently than we think. Scientists believe that some 3 billion years ago, Mars might have been more hospitable than Earth, hosting a diverse level of life forms. But Mars's small size worked against it. As a result of having a much smaller core compared to Earth, Mars cooled much faster and lost its magnetic field. This left it exposed to a constant stream of violent solar winds that evaporated any traces of water from the red surface. This also led to the Martian atmosphere being slowly stripped away, resulting in a drop in pressure and making way for greenhouse gases to escape the surface. With this, we now know that every planet has gone through different phases in its history, and that even Earth might not stay the same forever. Although our planet has managed to achieve the right circumstances suitable for life, it will most likely change over time. But does this mean that some planet somewhere else in the universe could also be in the life-sustaining stage of its evolution? Let us know what you think in the comments, and we'll see you in the next video.